Good morning. Today we are going to start chapter 10, which is entitled The Center of Gravity. Now, thus far we've been using the term gravity to describe the pull of a massive object on another object, typically one that has less mass. But what you should realize is that gravitational pull deals with all different objects, no matter how big or how small. And so in this particular lesson, we're going to try to find where does the force of gravity actually emanate from? Where does it come from? In other words, if you're talking about a person or a planet or an electron or a kid's toy, all right, where does where is the center of that gravitational field coming from? So Section 10.1 addresses the center of gravity directly. And by definition, the center of gravity is the point located at an object's average position of weight. All right, the point located at an object's average position of weight. Now, for a perfectly symmetrical object, like a ruler or a meter stick or that sort of thing, it's fairly easy to determine where the center of gravity is. All right, it's right in the middle. Okay, if you look at the picture that is on this slide, the cylinder that you see in the upper left-hand corner shows the center of gravity as a red dot sitting equidistant from either side of this. All right, I don't know if you can see the pointer moving, but here are the two ends of this, and the center of gravity is literally right in the middle. Now, for asymmetrical objects, objects that are not evenly shaped, if you will, the center of gravity will always be toward the heavier end. Again, in these two objects here, the center of gravity is located toward the heavier end. You can see this in this object, whatever it is. And looks like an axe handle or something along those lines. All right, the center of gravity is not in the middle here, but rather toward the left-hand side. The same thing is true of this brush that you see here. All right, the middle of this thing is somewhere toward the right-hand side of that point G, but the point G represents the center of gravity. Perhaps an object that you would be very familiar with would be a spoon. You ever balance the spoon on your finger? All right, well, it doesn't balance if you put your finger equidistant from either end. It balances when you put your finger toward the cup portion of the spoon. Okay, and so that's where you find the center of gravity for an asymmetrical object. In addition, objects that have varying densities, in other words, objects that are made of two different kinds of materials, may also have centers of gravity that are located far from their centers, from their actual geometric centers. Now, interestingly enough, if you take an object and throw it, okay, it will actually move such that the center of gravity travels in a parabolic path. Now, when we were talking about projectile motion, shooting a cannon or kicking a ball or that sort of thing, we were talking about a geometrically perfectly shaped object, a ball or a cannonball. And so it would travel along a path that is parabolic and end up on the ground somewhere else. Well, it turns out that if an object is thrown, it travels through the air such that that parabola is actually the point at which the center of gravity is traveling through. And so, for example, I think this thing is supposed to represent a baseball bat, and the center of gravity is located about here. And so it spins around such that the center of gravity travels this parabolic path. Okay? And this is true no matter how fast it rotates or anything else. Have you ever taken a baseball bat and just kind of flipped it into the air and had it spin around and land on the ground? If you watch it very carefully, you can see that it's the center of gravity. It is spinning about a very specific point, and that point is the center of gravity. This is even true for objects that explode. And so if you've got a projectile, a cannonball or a missile or something that explodes in the middle of the air as it's traveling somewhere, all right, the pieces of that projectile still travel such that their center of gravity follows a parabolic path. Now, I don't know that you'll actually be able to click on this hyperlink from the video, so I'm going to attach both this video here, the MP4, as well as the PowerPoint here for center of gravity. Please click on this link and watch the YouTube video on center of gravity, because it really does a very nice job of illustrating how to find the center of gravity, especially for an asymmetrical object. Okay, there is no homework for tonight. Just please watch the video, look at the PowerPoint, and read section 10.1 in your textbooks. Thank you, and I'll see you later. Happy March 27th.